Okay, class, so we are going to learn a new concept here. It's called the Bohr-Rutherford model, and we're going to learn how to create Bohr-Rutherford diagrams for different elements. Okay, so who discovered some information about Bohr-Rutherford diagrams? Niels Bohr, a Danish physicist, suggested that electrons move around the nucleus in nearly circular paths called orbits. So we learned that. We know atoms have a nucleus and orbits. Each electron in an orbit has a definite amount of energy. So guys, depending on the orbit that the electron is in, this changes the amount of energy that that electron has. Okay, so key here again is that electrons are moving around the nucleus in the orbits. They're not located in the nucleus. They move around the nucleus. Electrons cannot exist between orbits, so they don't exist in the empty space between orbits, but they can change orbits by jumping up and down between them from one orbit to another. So the order of filling electrons in the first three orbits is, so in orbit 1, there is a maximum of 2 electrons. So I'm actually going to draw a little diagram here. Okay, so we'll see more of these in the future slides. But this first circle, guys, that's just going to represent the nucleus of an atom. And we know that in the nucleus, we put the protons and we put the neutrons. That's the nucleus. This would represent the first orbit of an atom. So that first orbit can only contain 2 electrons. Okay? Oops. 2 electrons. In the second orbit, okay, so I will highlight that, and the second orbit, max is 8 electrons. So the first orbit can only hold 2, but the second orbit can hold 8 electrons. So I'm going to draw a second orbit here. And when placing the electrons in the orbit, you draw them in this order. The order is very specific. So when you go to place electrons in the second orbit, we know the max number is 8. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then lastly, this third orbit here can also hold a maximum of 8. So again, I'm going to draw one more orbit. Sorry, it's not as neat as I would like it to be. And same thing, this orbit can hold 8. So I'm going to go, actually going to use a different color just so that you can see better. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the first orbit can hold 1, 2. The second can hold 1, 2, 3, 4, 5, 6, 7, 8. And then the third orbit is the same, 8 as well. So each orbit contains a specific, or can hold a specific max number of electrons. So it goes 2, 8, 8. Electrons are more stable when they are at lower energy and closer to the nucleus. So the electrons that are closer to the nucleus, guys, they don't have as much energy and they're considered to be more stable. Okay, so this diagram is showing a Bohr-Rutherford diagram of the nucleus and the orbits, and it's depicting how many electrons each orbit can contain. Okay, so I kind of got ahead of myself. The Bohr-Rutherford model is also shown on this slide as well. So the center is the nucleus. So again, this here represents our nucleus. So we always have in place the number of protons and the number of neutrons inside the nucleus. Okay, and then the orbits, okay, so these rings here, those are going to hold the electrons. So the green are our electrons, okay? Keeping in mind that the first orbit, okay, the first orbit contains 2 electrons, the second contains 8, and the third also contains 8. Okay, so protons and neutrons go inside the nucleus, and then the number of electrons go on the orbits. So we're going to do a couple examples here. It says draw the Bohr-Rutherford diagram for oxygen. So you need to get the specific information about protons, electrons, and neutrons from the periodic table. So I have a little diagram here of what you would see on the periodic table for oxygen. So you'll notice 8 is the atomic number. Well, we know that that also represents the number of electrons and protons. Okay, so for oxygen, get this in green. So we're dealing with oxygen here. The number of protons is the atomic number. So we need to be able to pick that information out. It's 8. The number of electrons is also that same number, the atomic number, which is 8. And then the number of neutrons, remember, in order to get that, we have to take the mass and subtract the atomic number. So the mass is 16, we're going to subtract 8, and we're going to get 8 neutrons. So we need to figure out this information first before we go and do the Bohr-Rutherford diagram. So now I'm going to place my protons and neutrons in the nucleus. So I know I have 8 protons and 8 neutrons. Okay. Now, the first orbit is going to contain 2 electrons. So keep in mind, this is important, we have 8 electrons to place inside the orbits, because remember, only the protons and neutrons go in the nucleus and the electrons go in the orbits. So if we have 8 electrons to place, well, the first orbit is only going to contain 2. So I'm going to draw the first orbit here. Okay, and that orbit is going to contain 2 electrons. The second orbit, so now if we've placed 2, we have 8 total, that means we only have 6 left. So that means that this second orbit is only going to have 6 in it, and that's okay. It can hold up to 8, because remember 2, 8, 8. It can hold up to 8, but we only need to put 6 because that's all we have left over. So I am going to place the remaining 6, and again, remember, in this order. So 1, 2, sorry guys, the touch screen's giving me problems. So yours will be better, yours will be more circular. Mine are coming up a little bit more rectangular, but the norm is for them to be circles, okay? So 1, 2, 3, 4. Okay, so 2 in the first orbit, and then we have 6 left. So 5, 6. Okay, so for a total of 8 electrons. So 1, 2 in the first orbit, 3, 4, 5, 6, 7, 8 in the second. Okay, so now we're happy. We've done the Bohr-Rutherford diagram. Let's do it again. So we are going to now do this for sodium. So same thing, I have this little diagram here. We have to pick out the information first. So we need to figure out number of protons, electrons, and neutrons in order to do the Bohr-Rutherford diagram. So based off of this diagram, we have our atomic number in the top left corner, which we know represents our number of protons and our number of electrons. So we have 11 protons and 11 electrons, and then to get number of neutrons, we have to take the mass and subtract the atomic number. So 22.9 is our mass, that rounds to 23. We're going to subtract our atomic number to get 12 neutrons. So let's draw the Bohr-Rutherford diagram. So remember, first thing are the protons and the neutrons that are just going to be written in the middle as the nucleus. Okay, so I'm going to put 11 protons, 12 neutrons right in the middle there. And then now I'm going to draw my first orbit. And I know my first orbit holds 2 electrons. But remember, we have 11 electrons to place in the orbit. So the first orbit is going to contain 2 electrons. So 1, 2. Sorry guys. Struggles here. Touch. Okay, so 1, 2. Now I'm going to draw my second orbit. So I've already placed 2 electrons, which means that I still have 9 left to place. Well, I know my second orbit can only hold 8, so I'm going to fill it, okay, because we're still going to need to place 1 more. So I've placed 1, 2, 3, 3, 4, 5, 6, 7, 8, 9, 10. So that's full now. It has 8, and now I have 1 left to place. So I'm going to draw a third orbit here. This can hold up to 8, but I only have 1 left of the 11 to place on the orbit. Okay, so protons and neutrons go inside the nucleus. First orbit holds 2, second 8, third 8. In this case, with a Bohr-Rutherford diagram for sodium, I only had 11 electrons to put on the orbits. So 2 in the first, 8 in the second makes 10, which means I had 1 left over to put in the third orbit. Okay guys, we will do some more Bohr-Rutherford diagram practice when we do the review lessons during the Teams meeting. Okay, now we're going to move on to Lewis symbols. So if you can do a Bohr-Rutherford diagram, the Lewis symbol is very straightforward. So let's look at the periodic table briefly and just pick out some information that it tells us. So what do group numbers and periods tell us? So a group number is the number of electrons in the outer orbits. So every atom or element has a certain number of electrons in its very last orbit. Okay, so the last orbit of the Bohr-Rutherford diagram is holding, it's called the valence orbit or the valence shell because it holds the valence electrons. And valence, guys, just means the last shell, the outer shell. So on a periodic table, group numbers tell you the number of electrons in the last orbit for each element. So if you look over here in this diagram, guys, group numbers are along the top of the periodic table. Okay, so this is 1, this is 2, and if you were to continue on, you know, this here, this here would be group 3, group 4, group 5. You'd continue on. This is group 13, 14, okay? So along the top of the periodic table, those numbers tell you the group number. So hydrogen, lithium, sodium, over here, those guys are all in group number 1, and they all have 1 electron in their most outer shell. Period number is the number of orbits the atom has, and we'll find the period number going down this way. Okay, so group number is the vertical groups, period is the horizontal rows. Okay, so 1, 2, 3, 4 going down are the period numbers. So lithium, beryllium, and so on, boron, carbon, nitrogen, those are all in the second period. Sodium, magnesium, aluminum, those are all in the third period. That period number tells you the number of orbits the atom has. Elements in the same period have the same number of orbits. Elements in the same group have the same number of valence or outer orbit electrons. So just to give an example here, I'm just going to write this down here. If I was to just choose lithium, okay, which is this guy right here. If I was to look at the group number, well, the group number is 1, which tells me that lithium has 1 valence electron. And lithium is in the second period, or the second horizontal row. So that tells me that lithium would have 2 orbits, or 2 shells, okay? So keep those pieces of information in mind. Based on where the element is located, the group number is going to tell you the number of electrons in the outer shell, and the period number is going to tell you the number of orbits that that element has. Okay, so elements in the same group, okay, the vertical groups are going to have the same number of valence electrons, and elements in the same horizontal rows, in the same periods, are going to have the same number of orbits in their Bohr-Rutherford diagram. Okay, so this is important because this is going to help us with our Lewis dot diagrams. Okay, so Lewis symbols. Bohr-Rutherford diagrams depict the electron structure of the whole atom, and we've just seen this. So when we did our Bohr-Rutherford diagrams, we had our protons and neutrons in the nucleus, and then we placed our electrons on the orbits. But only valence electrons take part in chemical reactions. So that is why we have Lewis symbols. A Lewis symbol is a diagram composed of a chemical symbol, so that's the symbol for the element, okay, and dots depicting only the valence electrons, okay? So in this case, I have this little diagram for sulfur on the periodic table, okay? So if I was to go and draw the Bohr-Rutherford diagram for sulfur, I'm just going to do this quickly. I know that sulfur has 16 protons, 16 electrons, and 16 neutrons. Okay, because I do 32, subtract 16, get 16. So if I was to go and draw this Bohr-Rutherford diagram, I'm going to put 16 protons and 16 neutrons in the nucleus. And then I'm going to have my first shell that holds 2. Then my second shell that holds 8, which makes 10 of the 16 electrons. And then my third shell is going to hold the remaining 6. So for sulfur, I'm going to have 2 in the first, 8 in the second, which makes 10, and then 11, 12, 13, 14, 15, 16. So in the last orbit, I have 1, 2, 3, 4, 5, 6 valence electrons for sulfur. So the Lewis symbol is taking just the symbol for the element. So in this case, that's S. And with no orbits, just the dots, I'm going to put just the valence electrons around the S, which is the electrons in the outermost shell, and I'm going to write them in the exact same way you see them in the shell. So in the last shell, I have 1, 2, 3, 4, 5, 6. Okay, so see how the dots around the S are in the same format as in the very last shell of the Bohr-Rutherford diagram. Okay, so Lewis symbols is just the valence electrons. Okay, so valence electrons, they are the outermost shell and are known as valence electrons. So we did already talk about this. I'm kind of a little bit ahead of the game. So in the outermost shell, so this is the, this is the last shell here, and this shell has 1 valence electron, okay? So for this atom here, the valence electrons are the electrons in the valence orbit, and then in this case, there is just 1. So Lewis dot diagrams, valence electrons are the only electrons involved in chemical reactions. They are easier and faster to draw than the Bohr-Rutherford diagrams. They help predict and represent molecules as well. So this is the Lewis dot diagram for chlorine. And remember, it's just the valence electrons, okay? So if you were to look for chlorine on the periodic table, you would find chlorine in the 17th group. So that's the second last column from the right. So that represents 7 valence electrons. So that is the shortcut in finding the number of valence electrons for an element and then being able to place them around the symbol in the same way you would have placed them in a Bohr-Rutherford diagram. Okay, so for chlorine, I would do Cl, and then I would place in the order 1, 2, 3, 4, 5, 6, 7. Okay, so it says draw the Bohr-Rutherford of nitrogen, and then draw the Lewis symbol. So this has been done here for us. So in order to do the Bohr-Rutherford diagram, guys, you would have found the number of protons, electrons, and neutrons. So we have 7 protons and 7 neutrons in the nucleus. And then based off the periodic table, you would have also found that nitrogen has 7 electrons. The electrons go in the orbits. So if nitrogen has 7 electrons, 2 are going to go in the first orbit, and then we're going to have 5 remaining. Okay, so then in the second orbit, you would place 1, replace 1, 2, 3, 4, 5 in that order. Okay, so in this second orbit here, that represents the valence electrons. So nitrogen has 5 valence electrons. 5 valence electrons. Okay, so when you go to do the Lewis dot diagram, all we need is the symbol for nitrogen. And then now we're going to, without orbits, just place those 5 valence electrons in the exact same order. So 1, 2, 3, 4, 5. Okay, we'll try a couple more. Okay, we're not going to do the Bohr-Rutherford diagram first. So we're going to use our shortcut. So remember, the group numbers are going to tell us number of valence electrons. So the shortcut is to go 1, 2. We skip the transition metals here. We'll learn more about that in our periodic table note. 3, 4, 5, 6, 7. So remember, those group numbers, or that shortcut there, is going to tell us the number of valence electrons. So I know that the valence electrons for this entire group here is 7. So fluorine, chlorine, they all have the same number of valence electrons. Oxygen, sulfur, they all have 6 valence electrons. So if they're in the same group, you're going to use this shortcut to determine the number of valence electrons, which will help you to do the Lewis dot diagram. Keeping in mind, when you label the periods, which are the horizontal rows, 1, 2, 3, 4, that tells you the number of orbits. So you know that if we're going to start with sodium, sodium is in the 3rd row right here, and it's going to have 3 orbits with 1 valence electron. Okay, so 3 orbits, because it's in the 3rd row, with 1 valence electron. So the Lewis symbol for sodium, first we're going to write our symbol. So first we're going to write our symbol, which is Na. And when we do the Lewis dot diagram, it's just the valence electron and how you would write it in the Bohr-Rutherford diagram. So we have just 1. So we put that dot right at the top, just like we would in the first orbit. In the orbit on the Bohr-Rutherford diagram. If we were to now do for chlorine, well, chlorine is right over here on the periodic table, guys. It's in the group that has 7 valence electrons. So I'm going to draw my symbol, and I'm going to put the valence electrons around the symbol just like I would in the last shell of the Bohr-Rutherford diagram in the order of 1, 2, 3, 4, 5, 6, 7. Okay. So that is Bohr-Rutherford diagrams and Lewis dot diagrams. I know this is new stuff, guys, so we will review this in our review lessons during the Teams meetings. You have a little bit of practice on pages 24 to 25 in your booklet. Thanks, guys.